Hello everyone. In this video we will try to solve this question from June 2018 CSIR exam. The question was asked for 4 marks, and in this question they want to know the difference between two basic name reactions, that is Shapiro reaction and Bamford-Steven reaction. Okay, so let's start. The major allylic alcohol A and the ester B formed in the following reaction sequence are. Okay, you have given this type of structure. This is called tosyl hydrazone, and you have given 2 equivalent of butyl lithium and 1 formaldehyde. You have got A, and after that you have given triethyl orthoformate, and this is called triethyl orthoformate, and propionic acid, it is catalytic amount, and temperature, it's a high temperature, 140 degree temperature, 140 degree Celsius. You have got B. Okay, now before starting to solve this question, you have to know two name reactions, that is Shapiro and Bamford-Steven reaction, and what it can do, and after that we will solve this question. Okay, so let us know what is the basic two reaction, that is Bamford-Steven and Shapiro. Okay, so I'm writing here. In Bamford-Steven reaction, the base which is used is a mild base, that is like potassium hydride, sodium methoxide, okay, like this one, and it generally forms this type of reagent, this type of name reaction, that is Bamford-Steven reaction, it generally forms more substituted alkene. Okay, and in case of Shapiro reaction, Shapiro reaction, in Shapiro reaction, the base which is used is a strong base. Strong base. Okay, so strong base like LDA, or the base which is used in the question also, that is butyl lithium. These two are quite strong base than these two, potassium hydride and sodium methoxide. That is it, LDA, and you may know the structure of LDA, and that is this one. I also made a video previously, and where I discuss on this structure of the LDA. Okay, and what it can do, in the Shapiro reaction, they generally always form the less substituted alkene. You have to know this. You have to know these things. Then you can answer the given question. Okay. Now let's start, and we will try to solve this question, and the mechanisms also. We will do the mechanism also. And before starting the question given, we will solve a mechanism. We will solve, or we will do a mechanism on these two reactions. Okay, to these two name reaction. First come into Bamford-Steven reaction. Okay, so I'm starting from this structure. I'm writing this to AR. Okay, this is the structure, and R over here, and I'm already said that this is a base which is used in Bamford-Steven, that is NaOMe or potassium hydride, like. Okay, so we have chosen this base, NaOMe, sodium methoxide, and what it can do, This is a base actually, this kind of, and this I'm writing this hydrogen like this. This is a base and it is used in only one equivalent. Okay, one equivalent. And this OMe minus is can attack over here hydrogen and the negative charge over the nitrogen. This is because of this acidic proton. This is quite acidic. Okay, this one like this. Okay, and this was this. Okay, I'm writing this is R and R, this is R prime. And then we have, then after that this is bond, this lone pair goes here, and this is a easily living group. This is a quite good living group, so it can live from the system easily. And after that this will form the structure like this. This is minus, this is positive charge over here, and this one. Okay, and after that heat has to be used just because of this. And now see, if we write the structure like this way, this one and this one. Okay, I'm writing triple bond N, and this is pi plus, and here is the minus charge, and this one. And now see nitrogen, this is a nitrogen, it can easily leave from the system as a gas, so nitrogen leave from the system, and there is a negative charge over this carbon, and after leaving of nitrogen there is a formation of carbene. So now heat, now due to heat presence from the system, and there is a 1-to shift, 1-to actually hydride shift occur. And due to this hydride shift, like this way, due to this hydride shift there is a formation of alkene, and you easily see here that this is a more substituted alkene. You can easily say that this is more substituted. This is more substituted. Okay, now let's come to the second type of named reaction, that is Shapiro reaction. This is Shapiro reaction. Okay, now see, there is a compound same like this way, and already said that the base which is used in Shapiro reaction, that is LDA or butyl lithium diisopropylamide or butyl lithium. So if butyl lithium is used, and now you have to check, you have to keep in mind that the butyl lithium which is used is in 2 equivalent amount of used, just because of there is a one acidic hydrogen, and this hydrogen is also acidic, but it is much more acidic, that just because of it is attached to the nitrogen. And first the abstraction of proton from the nitrogen side. Okay, and the second, this is one equivalent, and the second equivalent used here, and this is also a hydrogen, and this hydrogen also abstracted from the system simultaneously. Okay, this one, so this is hydrogen, and this is, and now see, this is all. Now the negative charge can go here, it can go here, and there's a 2 is a living group, I already told that. And after that the formation of this type of structure occurs, and double bond in, here is the minus charge. okay, and the Li plus is coordinated with it. And now see what happens in the next step. There is next step is like this. The negative charge can attack goes here due to it can easily leave from the system as a nitrogen in gas, and there is a formation of a negative charge. You can write the negative charge also, or you can write this is because of a negative charge, so it can coordinate with the lithium side easily. And after that you have to given a aldehyde. You have to given a kind of electrophile. In the question, the electrophile which is given as in the form of formaldehyde. Okay, we will do that when we solve this question. Okay, here is the electrophile. Just because of this can attack the electrophile, sorry, this one. Okay, so this is the basic thing that you have to know to solve this question properly. Okay, now let's come to the question. Now the question is this. Okay, I'm writing this structure here. You have given 2-butyl lithium. This is 2 means 2 equivalent. Okay, now see if this is a form of tosyl hydrogen, and you can easily form tosyl hydrogen from this structure, that is 2-methyl cyclohexanone. You can easily form this to this by using TS tosyl hydrogen. Okay, and if you cannot do so, then you can go over here. I will attach the link. I will attach the link in the iCard button. Okay, then you can see I already made a video on this topic in the previously made video. Okay, then you easily solve how to. Then you can easily do this to this easily. Okay, now let's come to the question. Then 2 equivalent of butyl lithium is occurred, and I am already said that in the here, that is, this is formed, Shapiro reaction is found less substituted, and this is found always, this Bamford-Steven is always found more substituted. Now 2 equivalent is given. See, butyl lithium, there is a 2 acidic proton, actually 3 acidic proton. There is a acidic proton from this one is acidic proton, this hydrogen is also acidic proton, and this hydrogen is also acidic proton. But in case of Shapiro reaction, you can easily check the reaction whichever you have given that the reaction is either Shapiro or Bamford-Steven. You can easily tell. So this is there is a butyl lithium which is given. So there is a 2 acidic proton. Now see, this is so in this question which we have taken from the CSIR exam, that is Shapiro reaction. So Shapiro reaction always form less substituted. So this hydrogen is abstracted from this side, not this hydrogen. Okay, so 2-butyl lithium is occurred here, and this one this, and this goes from here. And now send triple bond N. Here is a minus charge. There is a new bond formation occur, and this bond go here, and this is go here. Okay, so there is a lithium ion coordinated with this side, and after that you have given a formaldehyde. Okay, so what it can do, it can attack on here, and in presence of, you can easily draw the structure, or you can get easily this kind of structure. This is here, this is CH2 and OH. Okay, so you have reached the structure A. Okay, now let's find the structure which is given in the question. That is this is the option A. which is our product also, and this one is, sorry, this is not our option just because of this is more substituted, but we don't want more substituted. The Shapiro reaction always forms less substituted product. So now comes to option B, and this is a less substituted one, so it might be our option. Or this cannot be our option, or this is also our option. So you have in the question you have already mentioned that is major allylic alcohol. This is allylic alcohol. This system is called allylic alcohol. Okay. Now comes to the second part of the question, that is you have to given this okay, triethyl orthoformate. So what is the structure of it is? What's the structure of this? This is the structure of this, like, okay. Now in the presence of propionic acid, so what is the structure of propionic acid? The structure of the propionic acid is CH2, CH2, So that means this condition is given in the acidic medium. Okay, so if this is in acidic medium, then this is a lone pair of electron. It can easily abstract a proton. Actually, this proton from here. So if this proton decompose like this way, so H plus. Okay, then there is a formation of this one. Okay, now this oxygen also lone pair, it can push here and it can leave from the system, and after that there is a formation of this, so AT and OAT. Now see, now then you have to give a structure like this way, and sorry, you have given a, you have already got the structure A like this, and this lone pair of oxygen can attack on the carbon, and this is go back to the oxygen atom. Then there is a formation of C, there is still OET, here is a OAT another, and here is a O, H, this is positive. Okay, like this one. Now this hydrogen is here. If this hydrogen leaves from the system, then it also has a lone pair of electron. It can capture this hydrogen. So I write here like this way, minus H plus plus H plus. Okay, now this one goes here. Sorry, this is CH2 actually. This is O, C, OAT, and this is OAT, and captured the hydrogen also, and this is like this way. Okay, this hydrogen, this methyl group, actually I am writing this way. Okay, now see, here you have this kind of negative charge on the C carboxylate type anion, so it can abstract the hydrogen from here, it goes here, and it can leave from the system like this way. Okay, then after that there is a formation of this type of structure. OCH2 and OET. Okay, now and then you have given a heat. You have given this heat. This is major amount of it. Okay, so 140 degree temperature. So here 140 degree temperature has a great role, that is 3,3 Sigmatropic rearrangement. Okay, now see how the 3 sigmatropic rearrangement will occur. Now if we numbering from this side, this is from this side actually, and from this side oxygen has a more preference 1, 2 and 3, and here is also 1 and 2 and 3. Now see, you can easily solve this question, that is this basic 3 sigmatropic rearrangement, we all know that. Then how to do? So what actually occurs here, that is this double bond goes here, this is the number 3 hydrogen here, and this go here, and this is go here. Okay, now your actual product is, so here this bond is, there is no bond, just because of this height this bond is migrate to this side, there is 2 number I'm writing over here. So this, now there is a CH2, there is a methyl group, and this is a CO2 80. Now this is your final product. Okay, so now check with your option that in which option, and already we ruled out these two option A and D, and we have already left these two option B and C. Now see, this cannot be a possibility, this cannot be an option, so your only option that left, that is option number B. So this is your final product. Okay, so this is your final product, that is B. Okay, so I think I will cover all those concepts related to this topic and to the question also. And if you find this video useful, so then please subscribe to my channel, and so that's it. See you in another video. Thank you so much for watching. Have a great day.